Hi guys, there's been a request from a couple students if I could make a review video just to go over one more of each type. So as you already saw in Google Classroom, I had some guest stars already do some for you. So we already did an add and subtract here. So I'm going to go ahead and do one from 8D, which is multiplying. And I'm going to choose this one. Okay, so we're going to double distribute. 3w times 2w is 6w squared. Don't forget the squared. And then 3w times negative 6 is negative 18w. And then to complete the rainbow, we're going to do 5 times 2w, which is 10w. And then 5 times negative 6, which is negative 30. And then don't forget to add like terms if there are any. And the ones in the middle are like terms, so we're going to add those. So final answer, 6w squared minus 8w minus 30. Okay, and then on to factor out the greatest common factor. Let's do number 10. Okay, so the greatest common factor of 5 and 15, we can divide out of 5. And then if you look, they both have g's, so we can pull out the smaller amount, which is g squared. And now all you have to do is divide that out of both. So 5 divided by 5 is 1. There's still F4, and if you subtract the g's, there's 3 remaining. And then plus 15 divided by 5 is 3, and it looks like the g's are gone because 2 minus 2 is 0. That's it. GCF is just that one step. And then another one of our guest judges or guest stars already did number 11. So I'm going to do another one from here, maybe a little bit harder. Let's try, I don't know, maybe number 13. Okay, so this is the factoring trinomial section. But the first thing, remember, you always look for is a GCF. And I think all of these can be divided by 4, actually. Let's try. So if you divide everything by 4, you get 2x squared plus 15x plus 27. And now we can factor the trinomial by guess and check method. Okay, so to get 2x squared, we need a 2x and a 1x. That's obvious. And then to get a 27, that could be what, 9 and 3 or maybe 27 and 1. And the good news is, since it's plus plus, we know they're both going to be plus. All right, let's play around. I'm going to try the 9 and the 3 first. Let's see. So let's say we put the 9 here and the 3 here. I have no idea. I'm just guessing. We got to check, do the inners plus the outers add to 15? Oh my gosh, you guys, we got it right away. 9 plus 6 is 15. So we're done. Bring down the GCF, and that was the answer. Now, if it didn't work, then you would try maybe switching the order, or maybe you would try the 27 and the 1, or switching the order, but that covers that. Also remember, if the leading coefficient is negative, to always divide by a negative 1 first. Okay, on to the difference of two perfect squares. Okay, let's try number 20. First thing, GCF. So what is the GCF? What can we divide 18 and 32 by? And the answer is 2. So let's start by just dividing every piece by 2. and you get 9m squared minus 16n squared. Okay, but that was only the GCF part. Now we actually have to do the difference of two squares. And luckily, these are both perfect squares, so we can do our thing. Okay, so to get 9m squared, we need 3m and 3m. To get 16n squared, we need 4n and 4n. And then to get a negative, we need a plus and a minus. And now you're done if you remember to pull down the GCF. So that's how you do the difference of two perfect squares. Just remember, if they're not perfect squares already, to pull out the GCF first, and then they will be. And the last section, factor completely. These are problems that might have multiple steps. So I actually want to do two of these. Let's do number 1 first. What is the GCF? What can you guys divide every single piece by? And hopefully you're thinking 3x. All right, let's do that. If you divide every piece by 3x, you get 1x squared plus 11x plus 10. And then we're not done. Now this is a trinomial, and to factor a trinomial, we guess and check. So to get x squared, we need x and x. And now we need two numbers that multiply to 10, but then they have to add to 11. So that's obviously 10 and 1. Because everything's plus, it's plus. And don't forget to bring down the GCF. So that's number 21. Okay, I also want to do 23. I thought this one was a little weird. 23, it's actually a shortcut of the factor by grouping 4 terms. See how it's already set up where these are alike? And then remember, when you have that, you pull that out, and then the other parenthesis is all the other stuff, m plus 5. Remember that from factor by grouping? So the common factor comes out, and the leftovers go in the other parenthesis. But we're not done, because this is the difference of two perfect squares, so we can do more. And that factors to, so to get m squared, we need m and m. To get 9, we need 3 and 3. And then 1's plus and 1's minus. And then don't forget to pull down the m plus 5. And that is fully factored. All right, guys, summative is tomorrow. Make sure you do all of these problems and check the answers. And good luck.